Okay, we now have question 18. Question 18 literally talks us through the derivation or deriving of the quadratic formula. So we have, we'll start off with 18a. We have y equals ax squared plus bx plus c. Now, when we're completing the square, the first thing we want to do is make sure that we have, we want to factorize the first two terms to end up, I was hoping that would be a straight line, to end up with a on the outside of the bracket so that x squared has nothing in front of it. So for the first two terms, I'm going to take a out the front. Then I've got x squared plus, and I want to have bx, but I had to divide it by a to make that work, plus c. Okay, I'm just going to rewrite this. Y equals a outside of x squared plus b on a x plus c. Now this term here is what I'm going to have to get to my next point. So I have y equals a, x plus b on a on 2 squared. Take. Now, normally you'd just want to do b on a, oh sorry, I should have done that smaller, b on a on 2 squared. But we also have to remember that it's a times as well, and then plus c goes on the end. So this b on a on 2 is here, and then this a popped up here as well, because when the b on a on 2 is squared, it's also times by a, and we have to get rid of that, and then, yeah. Okay, let's just make this same line a bit prettier. So we're going to end up with y equals, we've got a out the front, x plus, now b on a on 2 is the same as b on 2a squared. Take a times b on 2a squared plus c. I'm going to expand the squared on the right hand side because I know what I'm aiming for. I'm aiming for this thing, and this whole thing on the right hand side, like you can see the squareds have been expanded, so I'm going to do that. Because on the left hand side, I'm there already. That and that, they're looking pretty good. I'm giving that a big tick. Okay, so on the right hand side of that, I've got, well, I'll just copy this thing. Take. Now, this is a times. This is b squared over, now that 2a is squared as well, which gives me 4a squared plus c. I'm not going to do this in pink, I'm going to do this in red. This a and one of these a's cancel out. So I end up with y equals, and I've got this first term again. There we go. Take, and now you can see that I've got b squared on 4a plus c. On this right hand side, I want to get them together. So y equals a outside of x plus b on 2a squared plus c minus b squared on 4a. If I decide to times that by 4a on 4a, then I'm going to end up with x plus b on 2a squared. This is just, by the way, if I had 3 take 4 on 2, then I do 3 times 2 on 2 take 4 on 2. Yeah. So I've got plus Now that 4a, that c times 4a is the same as 4ac. This is all over 4a, take b squared, all over 4a. I can now put them together. Y equals a outside of x plus b onto a squared plus 4ac take b squared all over 4a. Now, in the question that we're aiming for, it actually has a minus out the whole lot, out the front of the whole lot. Actually, I'll do that in red. Which means I'm going to have that b squared first because I want the minus out the front of the whole lot. Y equals, so I've got a x plus b onto a all squared minus, and this becomes b squared take 4ac all over 4a. That's what I wanted, isn't it? Hooray, I'm there. Okay, so 18b, which means this is in the same form as y equals a x take h squared plus k. But here, the vertex is at h comma k. Don't ask me what happened to this t. So h equals minus b on 2a. Hey, that's usually the thing we use. K equals minus b squared take 4ac all over 4a. That's not the thing we always use, but you know, it's a thing. Okay. 18c, put y equals 0 in order to find the, when it says the equation of the axis, that must be the axis of symmetry, minus b over 2a. Axis of symmetry, x equals minus b onto a. Okay, so we've got 0 equals a outside of x plus b onto a all squared take b squared take 4ac all over 4a. Okay. Now this is the same. There's two ways we could solve this, an easy way and a hard way. I'm going to go the easy way. I'm going to add b squared take 4ac all over 4a to the both sides. So I've got b squared take 4ac all over 4a equals a outside of x plus b onto a squared, yeah? Divide both sides by a. I've got b squared take 4ac all over 4a squared equals x plus b onto a. Square root both sides. I end up with b squared take 4ac all over 4a squared equals x, plus minus by the way, plus b onto a, which means square root of 4a squared, well that's just 2a, and I take that b over 2a over to the other side, so I get minus b over 2a plus minus square root of b squared take 4ac all over 2a equals x. Put them both over 2a, I get minus b plus minus a square root of b squared take 4ac all over 2a. And they're my x-intercepts. Sorry about squeezing that into a small amount of space. Write the quadratic in factored form. Oh gosh, this question doesn't want much, does it? Okay, 18d. So, I'm going to go back to here. Or should I cheat? Yeah, I'm going to cheat. Oh, sorry. Okay, I'm going to take it from here. So I got this thing, yeah? Which means x equals, I take it over the other, x plus b plus minus plus technically, the square root of b squared take 4ac all over 2a equals 0. So we have x plus b minus root of b squared take 4ac all over 2a, and we have x plus b plus square root of b squared take 4ac all over 2a equals 0. That's factored form. I don't know why they wanted to do us. We're never going to use that. Thanks, guys.